This is a video for 8C, column graphs and dot plots. So the most important thing up here, I reckon, is that we need to understand that graphs should include titles and labeled axes with any numerical values drawn to scale. We also need to know what an outlier is, so that'll be a new vocabulary words, and we'll need to interpret graphs, construct and interpret a column graph, and we'll be able to construct and interpret a dot plot. I think you know how to do these two already. Okay, a dot plot can be used to display discrete. Remember, discrete is counting numbers. Counting numbers. So like 1, 2, 3, 4, 5, where each dot represents one data point. So we'll talk about that in a minute. A column graph is a way to show data in different categories, and it's useful when more than a few items are present. Column graphs can be drawn vertically or horizontally. So right here is a horizontal column graph. We've seen these before. It has to have a title, so this is it, favorite color. It has to have an even scale, so notice it's 5, 10, 15, 20, and each one of those is the same distance apart. And then on the bottom, it might have categories or non-numerical labels on the bottom. Okay? And then this one says number of students, so that tells what's on this axis, compared to color, which is on that axis. Okay? And so this thing's a dot plot. So a dot plot looks a lot like a column graph, except each dot represents one piece of data, and those are numerical. So there's numbers down here, and I don't have an axis here. I just look at the dots and count them. So if I wanted to know how many 2s there were, I'd go 1, 2, 3. There's 4 2s. An outlier is when you have a dot that's way far away from the other data. Okay, so these are all clustered together, and then there's an outlier out here. So an outlier, I'm going to do this, is a value that is noticeably away from the other points. Okay, maybe we'll write it in our own words. An outlier is away from the group of other points. So there's the group of other points, and this is way far away from it. We also talk about data being symmetrical, so kind of going up and down under kind of the same on both sides, or sometimes it goes up way up at the beginning and then it trails off, and we call that positively skewed. Or it starts really slow and then it goes up at the end, and we call that negatively skewed. Okay? All right. Here we go. The dot plot below represents the results of a survey that asked some children how many pets they have at home. So you can already see that it's going to be numerical because they're going to say how many, a number. Get that out of the way. So it says use the graph to state how many children have 2 pets. So you can pause if you want to and put your answer down. 1, 2, 3, 4. I'm going to say 4 have 2 pets. This says number of pets, and this says number of children. So 1, 2, 3, 4 children have 2 pets. How many children participated in the survey? That means I have to count how many are there. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Looks like 21 to me. What is the range of values? Well, the most children, the most pets anybody has is 8, and the least pets anybody has is 0. So the range of values is 8 minus 0, which is 8. What is the median number of pets? Well, if I have 21, I would count in 10 from each side, and I'd be in the middle. So I'm going to do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's from one side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like that's the middle value, and that is a 1. So the median is 1. If you have trouble doing this, you'll have to write down all the numbers of pets. So you might write a list and go 0, 0, 0, 0, 0, because there's 1, 2, 3, 4, 5, then 1, 1, 1, and write these all out if you have trouble counting from either side. Excuse me. The outlier is 8. We can see it's far away from the others. What is the mode? What's the one that appears the most? Well, that appears 5, and that appears, oh, I can see, that's definitely the most. So 1 pet is the mode. Next, we have to draw a column graph. So I want to make sure you can see this. I might just put this up a bit so you can see really well. So I need to draw a column graph to represent these people's heights. So for the title, I might put heights. Okay, and on this side, I might put the names. I might put Tim, and I might put Philip, and I might put Jessica, and I might put Donna, and I might put Nari. And I'll say, okay, I want to put representing their heights. I need to put some values here. If I put 20, it'll go 20, 40, 60, 80, 100, 120, 140, 160. That's fine. I could probably get away with putting 10 on each one. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 20, 30, 40, 50. That looks good. So I'm going to put 10 for each one. I'll pause for a minute while I do that. Okay, so I've done that. And now for Tim, Tim is 150. So I'm going to go all the way up. Usually I would use a ruler to 150. I'm just going to use the edge of my protractor because I kind of stuffed that up. And I'll go all the way down here for Tim. And I might color him in up to 150. Now Philip is 120, so I'll go up to 120. I might color Philip in solid. And Jess is 140. I should have put their names right under the, maybe I'll color her solid pink. And Donna is 100. And Nari is 130. I reckon I could have made this a little bit better by putting their names right under the bar. Maybe she'll get to be pencil. Okay, so that represents those people. And then here are your problems.